can't hear you. Let me turn on my mic. Like it's on actually.
Oh yeah, sorry, I was mute. So yeah, sorry. So I was
Okay.
saying,
Yeah.
um, yeah. First, if you are having like 2D array or 3D or ND array, and we need to get a single value, then probably we need to specify. We need this kind of approach, multi-level indexing kind of approach, where we need to specify a square bracket to get to the first index, like first top level index, and then another square bracket to access the second level index. And again, if even inside this we're having another list, then for sure we need the third square bracket. So that's the way how we can access the items. In this example, they're simply going to zero index, which is this, and then again going to second index, which is this, and we are getting 3. And yeah, this approach is also valid. Just specify a single square bracket and separate them by a single comma. It's like go to this index and then go to this index, and it will simply give you the same answer. But it depends which one you like. They both are pretty much same. And yep, that's what they are referring to access a particular thing. So if you want to access this item, you need to say 0,0. Why? Because let me share the pen. Yeah, this is the first array. Let's think of this as an array. These things are like arrays, so you could just think of like something like this. These are all are lists, and these 3 lists are again packed into a big list, something like this. And this big list has these indexes, something like this. On axis 0, yeah, on axis 0 we are having this index. If you wanna get this value, the middle one, so we just need to say 1, 1. On index 0 go to 1, and on index 1 also go to 1. So that's how it works. This is a good example. Like if you see something like this, then for sure this is a good example to understand. But I guess you're already familiar with these multi-level indexing, if I'm
Yeah,
not
yeah,
wrong.
yeah.
Same goes here. Array 3D, this is array 3D, and this is like a three-dimensional array. If you will notice, we are having this, like these two lists stored in this kind of thing, this matrix. And again, this matrix is stored in another kind of container, which is like this top level list. So if I'll say 0, it will go in this top level thing and will give me this first matrix. And yeah, that's what's happening. 1 2 3 4 5 6, I'm getting this matrix. And yeah, here they have created a copy and changed that into 0. They're like array 3D, so they're changing the original one. They're like go to index 0 and change that to 42. On index 0 we are having this much part, we are having a whole matrix, and everything inside that matrix would be changed to 42, and the remaining second matrix would just simply stay the same. And yeah, this time they had, before changing that stuff, they have created a copy and stored in this, and now they're again replacing that stuff, and they get the original thing. That's nothing, they're just playing with that stuff, multi-level indexing and that stuff. But yeah, that's it. Oh yeah, go to index 1 and then 0. So yeah, on index 1 we have this matrix. On index 1 we have this matrix, the second matrix, and then go to index 0. Index 0 would be like this thing, the first list. And yeah, that's what we're getting. Store the second matrix in this list, and yeah, that's what we're getting. And yeah, this for the original thing. And yeah, now here we go with the slicing. Indexing with slices, nothing special here. They're just like start from 1 and end just on 6. This is like 1 2 3 4 5 6, so it's gonna end somewhere here, like one number behind that stuff. So yep, if we are having 2D NumPy array and if we say start from 0 and end on 2, so what it will do, it will start from 0 and 1 and it will just end before 2, so it will only have these two, the first two lists, and that's exactly what we're getting here. And what's here? Array 2D. Okay, where is array 2D? This is our array 2D, and what they're really saying, they are like, on first top level index start from 0 and go up till 2. So what will happen, yeah, on top level index it will start from 0 and then 1, but it will not go to 2 because it ends before 2. So we are getting this thing, and after that we are like start from 1 and go up till end. So what's happening, they're like starting from 1 and going up till end. Oh, in this thing, start from 1 going up till end, start from 1 going up till end. So we're just getting these four values, if I'm not wrong. Yeah, 2, 3 and 5, 6. I hope you got this stuff right, or do we need to code that down in VS Code?
No, I understand it. I do.
Okay, and that's great. What's happening here? Yeah, they're like, okay, go to index 1 and then for top level index, for access 0 go to index 1, and for access 1, if I'm not wrong, for access 0 go to 1, for access 1 do something like this, start from start and end on 2, which is just like 1 before 2, and that's what we're getting. 4, 5, let's tally that stuff. They were like go to 1, yeah, we are here, and then they were like start from 0 and to go up till 2, so it's like 0, 1, obviously it's not gonna add 2, so that's why we're having 4 and 5. Yeah, 4 and 5 right here. Simply here they're just, you know, playing with that. And what we have here, we are like on index, on axis 0 take everything, but on axis 1 start from 1, start from 0 and end up till 1. So this is just basically gonna pick up all the values in 0. And if I talk about this thing, it will take all these things and just take this, this and this, because they're like colon and after that 1. It will not exactly go to 1, it will just stay on 0. So we are getting 147. Yeah, that's what we're getting. And here like they're like on axis 0, start from 0 and go up till 2. That means axis like oh yeah, sorry for that. Here they were, what they were saying, oh yeah, on axis 0 start from 0 and end up till 1. So they're just picking first two lists like this and this. And for the second one, second axis 1, they're like start from 1 and go up till end. So they are starting from 1 and going up till end. We are getting this 2, 3, 5, 6, 8, 9, if I'm not wrong. Oh, have they changed? Oh, they're like, oh, do that to 0, they are not accessing, so do that to 0. So yeah, if you could see, they are, yeah, the same values are getting updated. They have been converted into 0. And yeah, this is also good part to practice. If I specify, if I write this code, basically this part of the array would be selected. Remember, all of these cubes are 2D. No, nothing is
Yeah.
3D or 1D, you know.
Do you think this is in any way useful for CNNs when working on in machine model? It
Not
looks
really.
like max pooling to me.
Yeah, you could say, but even that is, you know, automated. We just need to write 3, 4 words or even one line, and that happens. But generally, working with,
You know max pooling where it's going on pixels
yeah,
in
just picking the
CNN.
maximum values. Yeah,
Yeah.
yep. In order to understand max pooling, maybe you need this concept how that happens, but not
Yeah, I
really
mean,
actually.
I'm just Just making a wild guess. Not that I mean, you don't do the max pooling manually anyways. You just ask the you just pass it as a function, so to say, and CNN does that. Um, the
Yeah.
algorithm does that for you when you run or um, yeah, when you what do you call it? When you build the model and then
Yeah.
you run it. Yeah,
Yeah, you're
yeah,
right.
when you fit the model.
Yeah, fitting the model or training the model is kind of different part, but most of the thing you would learn from this book, as per the title of this book, you could simply say like, Python for data analysis. Probably like we are just learning the part of NumPy and pandas, and we would be simply dealing with the pre-processing part. So nothing learned here would be really useful if you talk about training the model or that time. But yeah, in pre-processing you really need these kind of concepts, because sometimes you're like, oh, I got maybe some NANs, empty cells, and they are categorical, and you're just running a command and picking up the unique values of that particular feature. Probably that's like if a student is good, bad, or job roles in a company. They are having different departments, R&D and HRs, and different, and in that column some of the values are missing. So you're just doing numpy dot unique and getting up the unique values, and then this command is used quite useful, to slice up the values or that stuff. Other than that, I don't really see this kind of part being utilized in training process or something. But for sure, yeah, in visualization and pre-processing, yeah, we really need that. We don't need that extensively, but sometimes we can get stuck if you don't really know this stuff. But you already know this, so yeah, that's really great. And yeah, that's nothing. Just how to pick up these things. So I need all of on axis 1, I need all of these things, and on axis 2 I only need these two values, and that's what they're saying. And that's the, I guess, the shape of the output. Yep. And yeah, here we go. Boolean indexing. Here we go. This is a good example actually. Let's copy that and try to do that. Boolean indexing. So here we go. Here we have a NumPy array in which we have some names: Bob, Joe, Will, Bob, Willie, Joe, and down there we have a data, randomly generated data. But the good thing about, or the thing to notice about this data is like the shape of this data. As you could see, let's also check the shape of these names dot shape. If I check, the shape is 7, and here too we are having 7 rows and 4 columns. So I could tell you like each row is kind of connected to each name, or you could simply say this row is the school score, or like score for each subject. Bob have like every person in the school has 4 subjects, and these are 4 are the scores for each name in this list. This means like the first row is connected with this first value, and the second row is connected with this second value of the array name arrays. Like, did you got till this point? Like, did you got like how are they connected to each other?
I'm I'm trying to see how.
It's simple, nothing else. I'm like, this Bob, like this value in this array, names array, and this first value, it is kind of connected to this thing. It's not really connected, but I'm just saying that this first row in in this like data array is for like this value in the first thing. So simply like the first value in this thing would be used against this. Like it's simply like this. Like these all 7 rows are like associated or connected to this each name, like each value in this
Yeah,
array.
yeah, I
It's
understand. Associated. Okay. Yeah.
yeah, associated. Yeah, kind of that. And what they're doing next is they are like doing something like that. Yeah, names. They're like go to names and show me where we have Bob. So it will basically return me a true false kind of thing. It's like on index, this index, yeah, we're having Bob, but on this index, no, then a yes, then a no. So by this thing, this is just Boolean indexing. I can pass this indexing like this array and get the value of this thing. How? Something like this. Data inside the data, I can for sure get the first row by this thing, get the second row by this thing, or get the range of rows by something like that. But if I only want to get the rows which are kind of really associated with Bob, so I'll really need to pass this condition. I'm like, go to this data and use this kind of condition or the or like Boolean indexing. So firstly, this thing will happen. It will go to names and check where do we have Bob. So it will output this kind of Boolean array, and then this Boolean array is kind of replaced by this kind of code, back at the backside or in the background, and like that we will only get the rows which are kind of associated with Bob. How can we tally that? So the first row should be something like this. Yeah, it's like 0.65, and yeah, we're getting same thing. But the next thing was like 0, 1, 2, 3. The third row, like 0, 1, 2, 3, it's like minus 0.755 and minus 0.755. Yeah, that's how we can do that. It's nothing. Like I have another NumPy array, and based upon that I am evaluating something, and then I'm using that evaluation to bring up the data. This is like a good example. Let's suppose what can be that stuff. Yeah, there is a student, like at the back end we have a data, we have two separate arrays. One is in one array we are having simply the data set, and we have another array in that we have the names. So the data is like organized or like structured in such a way that each value, like it's organized sequentially, or like every value in this first array would represent something in the next array. It's not like we need to access that by indexing. Yeah, we need to access by indexing or something, but I don't know, maybe I'm making that too much complicated. Nothing like that,
Yeah,
but
yeah, yeah.
this thing is associated with this, and the second is with second, and you're like, I only want the data for Bob, and I can simply say this thing, and this thing returns me some Boolean thing, and then I can get only Bob. I can change the name. I'm like, I want to get the data for maybe Joe. If I do Joe, I'll get these 3 things. And how will I get these 3 things? I can just simply check that which row am I getting. I'm getting the first row, the row on index 1, the
So
row
first
on last 2
index one, yeah,
indexes. Yeah, that's how I'm getting,
like
and that's
minus two.
yeah, that's what they're really referring to. I could have even passed something like this, a custom Boolean thing, maybe like a true and then false and then again a true. But the thing is, the size should be same. The size of the true false should match this thing. It should match this thing. So let's do a kind of copy thing, and again pass the false. And yeah, this time I did that stuff, but I can do this with more kind of logic and in a more sensible way by doing something like this. And even though I can pass multiple kind of conditions, how can I do that? I'm like, okay, go and tell me where can we find Joe, and I can just put an and kind of thing, and I'm like, also see that the name should be equal to, I can use simply or instead of r, or the names should be equal to Joe. So this time I'll get the data both for Joe and Bob and Joe. And if I'll run that, value of which more than, I guess I need to make that into something like this. The truth value of the array more than the element. Oh my goodness. Bob, B-O-B-E, B-O-B. Oh, once more. If I do something like this. Probably. I need to see what's happening. Okay. Or maybe something like this. The truth value of an array with more than one element is ambiguous. Use something like this. Okay. Why is like that? They should have something like that in the examples. They're using not this operator, pipe operator. Okay. Yeah, that's what we need to use. We can't use or. And the symbol is and. The thing is, this will only return true if the condition by both of them is true. So yeah, we need to use this pipe instead of that true. So yeah, simply I can pass this condition right here, somewhere here, and this should work. So now I'm getting the data for Bob and Joe, both of them. But if I use AND operator, I will get nothing because no condition is like that. I can't find Bob and Joe on the same index. So yeah, that's what they were saying. But let's go up and see what exactly they wanted. They got the data for Bob. Let's read that. I guess they had explained that more good. Suppose each name corresponds to a row in the data array, and we want to select all the rows with corresponding name Bob. Like arithmetic operators, comparison such as equal with array are also vectorized. Thus, comparing names with the string Bob yields a Boolean array. Yeah, it yields a Boolean array. Then we can use pass with when indexing the array. The Boolean array must be of the same length as the array access it's indexing. You can even mix and match Boolean array with slice or integer. So yeah, that's what they're saying. Okay, yeah, we can mix match. We are doing something like this. We are getting data, and then on data I'm like, I need value starting from 2 up till and what they really mean is, if I do this or operator, if I run this, okay, I'm like, I only need these last 2 columns, so I can put up a comma, and I'm like from 2 up till the end, and here you go. I'm doing like that. That's what they're referring to. We can do that stuff too, and I can do not equal to Bob. So yeah, that's pretty much easy. I'm like, oh, let's create a new example. I'm like, give me all of them and only give me the data that is not equals to Bob. So this time I don't want Bob, but what's wrong with you? But I want data for all of them. So yeah, I got all of the data except the rows which were corresponding to Bob, and that's it. Even though we can use this not operator, this, like, I don't know what's this called, but yeah, this is like next to, like, it's on the left under escape button. Yeah, this thing, I don't know what this really is called. Let's Google that, what this really is. The symbol tilde, this is called a tilde symbol. So yeah, you can either use tilde symbol or you could just use this syntax. These are pretty much same. not equal to, or just specify the condition and then use the tilde sign. And yeah, same here, they're just storing the condition in a variable and then using this. This is kind of more readable. This is a bit, I don't know, messy or something. And yeah, that's what we did. We are like, go in names, give me Bob's, like give me the condition true if you see Bob or if you see Willie, and that's the condition. And then based upon that mask, we are like, go to data and bring up the values based upon this particular boolean array. And that's pretty much of it. And the Python keyword and or do not work with boolean array. Use and pipe instead. So yeah, this is a good thing to remember. Setting values with boolean array works in a common sense way to set all the values. So yeah, they're like, okay, go in data, and if the value is smaller than 0, then basically, you know, convert that into 0. Let's actually do that. That looks pretty good actually when we do that. This is the data, and I'm like, if the data is smaller than 0, this will basically return me a map, true false map, and then I can pass this map into the real data set and get up those negative values, and then I could just simply say them like, just make them equal to 0. And if I'll print that stuff, so here you can see every negative value is converted into 0. So yep, you can use these kind of condition and change the values to based upon the condition. Or you could do something like this, you know, where name is not equals to Joe, go into data and change that to 7. So like, do you see, that's now that's getting, you know, useful. I hope this
later the set of operations 2-dimensional.
Yeah, as we will see later, these type of operation on 2-dimensional data are convenient to do with pandas. Yeah, that's what they're saying, like changing the values, like specifying the indexes, or like, you know, fill up the negative values with something like that and that stuff. So yeah, that's what they're saying. Fancy indexing, do you have any idea about that? Fancy indexing,
Do I have any what?
idea about fancy indexing? Yeah, we discussed indexing,
No.
you know, and slicing.
Yeah, yeah.
But any thought on this fancy indexing?
No, I'm not.
This is like
Not.
it solved
It's
a
like a for
problem.
loop again.
Not really, like this is not what we really want. Let's kind of create this thing and try to see what they really want to teach us. That's the fancy indexing is quite useful. And let me create this array and ARR if I have this array. So yeah, if you could see, this whole bunch of data is our array. And right here, this for loop is doing nothing, but it's like, okay, for I in range something like this, I in range 8, it's starting from 0. It's like, go in array on index 0, change that to I. Obviously I have at the beginning would be 0, so you know, on index 0 it's changing everything to 0, and in 1 everything to 1. That's what this for loop is doing. We can do the same for I in range up till 8, and then I'm like, go to this array, go to this index I, and then change that to I, and this time our array would be something like this, you know, index 0 is 0, index 1 is 1, because I'm changing the value and the index with the same number. And what they want to say us is like, okay, now let's focus on that. To select out a subset of the rows in a particular order, you can simply pass a list or ND array of integers specifying the desired order. Okay, that's pretty kind of okay. What fancy indexing really means. If I go here, in normal kind of indexing, I could have done something like this. I could have done, okay, first what do they need? They need the 4306. 4306. Okay, I could just simply write 4, and for sure it returns me this kind of 4. But what if like by this, for sure I can go into this fourth row and then again go inside that fourth row by again specifying this, like bring me something like that, or I could even have done something like this. But it's this syntax is not allowing me to select multiple rows. So for that, we have a concept of fancy indexing. What that really is, I have defined a square bracket, and again inside that square bracket I can again pass a list, or you could say a double kind of square brackets. Right here I can simply pass the row number. I'm like, first I need the row 4, then I read row 3, then I read row 0, then I need row 6. So it will bring up like multiple kind of rows for me. Like you see, it's doing something like that. And after that, you could have specified like a comma or something, previous stuff, what we used to do. We used to do 4 comma, anything, or after that, or we could have even like wrote something like this, 4 comma something like that, and that we can really do that here too. But the thing is, this fancy indexing is just something like this. Instead of just writing one number, we can pass a list of number or indexes, and that's all about fancy indexing. We can select multiple rows, and on them we can later on write any condition. Maybe I need the first value, or the 0th value, or the -1, or something like that, and I'll really get that. And that's pretty much about this fancy indexing. But the good thing about this is like it brings up the data based upon your sequence. If I'll write 6 and 5 and 4, for sure it will just bring me those values, but in a sequence which I have specified. First it's bringing 6, and then 5, and then 4. That's what they're talking about, talking like right here. Simply pass a list or an array of integers specifying the desired order. So they have specified the desired order, and yeah, that's exactly what they're getting. And yeah, you can do that in negative. And passing multiple index array does something slightly different. It selects a one-dimensional array of element corresponding to each tuple of list. I think nothing special here, just like it's simply like that. And yeah, you can even use that same approach with the next index. Like right here, what we were doing, I was like, yeah, go to these rows and bring me last value. But I can really specify, okay, for this row, the fourth row, bring me the fourth element, and for this third row, bring me the first element, and same goes for the next one. For the 0th row, bring me the second element, and for the 6th, bring me the 0. So obviously this time oh, what's happening? Index 4 is out of range. Maybe we don't have that much values. Yeah, now we are getting this. The thing is, I can't really differentiate which values is it picking, because all of them are same. But yeah, you can really do that. I guess they have an example for that. Yeah, this is their array, arrange something like that, and they're like, okay, bring me 1 5 7 2 row number 1, and then I don't know 5 and something like that. And then they're like, inside this first row, bring me 0, the element on index 0. Inside this first row, the value on index 0 is this 4. So they're getting 4, then they're getting 23 somewhere from here, obviously 5th row, and inside that 5th row, bring me the third value in third index. I hope you're like getting this stuff. That's fancy indexing. Yeah, double bracket. And yeah, simply you can play with that. bring me all of them, and then what they are saying, okay, bring me row 1572, and then what they are saying, then they have specified this, then they're like, again bring me everything. Oh my goodness, we need to break that down. That's too much stuff to decode. Okay, this is our array ARR, and now first part was to get this stuff. Yeah, that's pretty easy. ARR, something like that. Yeah, we are getting something like this, and then they were like, was this the example that we were referring to? No, this one was that example. Then they were like, bring up everything. I guess this doesn't matter because it's like starting and ending, like bring up everything. So they are just
everything
with us.
And 0, 1, 2, 0,
yeah
3.
it's yeah, if I pass this, nothing will change actually, because I'm like, bring me everything. Then I'm like, I have done something like here, like if you see something like here, we are getting this. If right here, if I'll do something like that, what if I'll remove this comma? Let's actually copy that and paste it here. If instead of comma I simply close this bracket and then again start a new bracket and then write this thing and a comma, then for sure it's doing, it's nothing really special. Then what's happening, it's like all of rows and then this.
It's like another list here.
I'm not really sure what they really want is. Okay, we got this column. Let me just do this part. 16, 17, 18, 16, 17, 18 up till like this part. We're getting this stuff, not exactly this, and then 12 and that part. And after that, what I'm saying, 3, 2, 1, something like that. Okay, I guess I got that. I guess I got that. So if I run this command, it will go into this array and bring me these rows. Okay, that's fine. Then after that, I'm again, passing these yellow brackets. If you see here, I'm having yellow brackets and then I have purple brackets. And what's happening here, this Python reads from like left to right. It starts from here and it ends here. After that, it returns me something new. And on that new thing, again, I'm doing the same stuff which I did here. It's something like that. Let me show you how it works. It's something like that. It's like let me paste this here. Let me just make a copy of this thing. It's nothing, but it's similar to that. It's like a is something like this, and then what I'm like on a, do again this stuff. That's what's happening. I'm like, going array, bring me this stuff, and I'm storing that stuff in a, and then on a, I'm like, bring me again this stuff. That's doing the same thing, but I'm just shuffling the rows again. Nothing to do here. Like if I'll run this, it will, oh, it's changing. It's just shuffling the columns actually. Yep, this is like take up all the rows and these are just columns. That's how the columns are shuffled. I'm like, first bring me the third column, and yeah, it's bringing me the third column. If I see here 0, 1, 2, 3, I'm getting all this. What do we have? 19, 15, 3, 27. Yeah, 3, 27, 19, 15. Yeah, I'm having that at the first position, because I have specified here for the first position. And for the rows, I'm like, go and bring them all, but for the columns, I have specified this stuff. I could have done this like up there, but yeah, that's again a fancy way to do that. This was the syntax to bring up the rows, or you could just put a comma and get specific values from those rows. And this is